There's 4 things I would like to cover in this webinar this afternoon. Why is big data important and how do we expect it to impact manufacturing? What are the challenges that we need to understand and manage to get the most from big data? So what is machine learning and how can we help maximize the opportunities and how the choice of the right tools might minimize the impact of some of the challenges we will face? Finally, I'd like to introduce you to SPM, Salford Predictive Modeler. It has recently joined the Minitab family of analytical tools, and through a short demonstration, I want to illustrate how easy it is to gain insights with large and complex data. The landscape with regards to data is changing rapidly. We're getting more data in terms of volume, the speed of arrival, and breadth. There is extensive research that is clearly showing that the winners in manufacturing will be those that can harness this data to make improved business decisions. We think this is a significant opportunity, but many of our customers are worried that they have been left behind because many haven't started taking steps to harness this potential. It seems that one of the barriers is that it seems to be an overwhelming and complex situation, and manufacturers do not know where to start. We really hope that we can help you on this journey. You may not be familiar with the term Industry 4.0. However, this is just a shorthand way of expressing the current trend of automation and data exchange in our manufacturing technologies. The machines that we are using to automate our processes are arriving with built-in data capture and storage capabilities. Data is being collected everywhere and is touching many aspects of your business. However, collecting data is not enough. To get a return on the cost of collecting and storing this data, we need to convert it into something that will allow us to make effective business decisions in a timely manner. Only by doing this can we harness the opportunity that these changes afford.
So at this point, we're going to go to our first poll question. So hopefully you're going to see this come up on your screen now. The first question we have for you is, what do you consider the primary practical application for predictive analytics and machine learning within your organization? And please tick all that apply. Product quality and defects tracking, improved manufacturing processes, predictive maintenance and reliability, root cause analysis, or supply chain planning and risk. We're just collecting the responses now. And I'm going to close the poll now. And let me, so interesting. It's quite a nice split there, as you can see. So yeah, I mean, we are seeing these this kind of split across the other research that we've been looking at Minitab. So this jives with what we've already been hearing from the market. So thank you very much for participating, and we will add that into our planning. I'm going to hand back over to Gillian.
So if these opportunities are so clear, what's stopped us taking this forward? So what we have learned from the market and our portfolio of customers is that data science skills to quickly and automatically get decisions from these large volumes of complex data are not there yet. Leaders are also struggling to make a quantifiable estimate of the potential return on investment, and they're expecting there to be significant investment requirements in this new world. They expect that digitally transforming their business will be hard, lengthy, and may not be executed successfully. What is also getting in the way is the existing technology infrastructure. Many companies still have legacy IT and siloed data. Getting these sources of data pulled together is definitely going to be challenging. I want you to remember that data is the foundation to harnessing the industrial Internet of Things potential. Even if you're not doing anything with your data yet, please start checking that you're keeping it in good order. The data is really the starting point and of key importance. On the path to the industrial Internet of Things achievement is a multi-layered, cross-functional, iterative process. You need to be working in partnership across your whole organisation. This is key. Building systems that harness, analyse, and translate data into actionable changes. You're going to need to integrate your machinery, equipment, and fixed assets with your technology so you can start to collect a data lake, making sure the data requirements are drawn out and captured appropriately. You will need to introduce automation to your data analytics to generate real-time, actionable, and prescriptive data capability. It is at this analytics automation stage where products like Minitab and SPM can help you deliver. There's no agreed ceiling upon the benefit that the industrial Internet of Things enabled organisations can achieve, but recognise that it has the potential to improve all of the key measures of your business. Smart organisations realise that their biggest differentiator is the data and their potential ability to unlock the value in it. The conversion of data into actionable decisions. I am certain that this will take a concerted investment in resources, but the potential upside that is unconstrained is definitely worthwhile to invest. I think it's really important to note that this is not constrained to just your manufacturing processes, but also to your functional areas that support your businesses, such as sales and marketing. In my previous life, I spent a large amount of time doing analytics trying to predict customers that were going to leave banks, looking at the attrition and the churn. At this point in time, we didn't have these tools to look at the multiple variables that we had available, not only from within inside our organisation, but also from external sources like credit bureaus. And you may need to look at other sources, not only within your organisation.
So at this point, we are going to go and ask you another question. This time we want to know, how ready is your organisation to handle data management and algorithm processing? Please select one of the following. Not ready, no specific tool or infrastructure in place, need to adapt current structure, you're able to handle data management and algorithm processing, or that you're ready and open to further improvement. And I'm going to give you a few moments to make your choice. Okay, so I'm going to close that poll down. And so again, we see a wide, hopefully you can see that. So as you can see, there seems to be a wide range of where different organisations are in that journey, with 14% saying you're not ready at all, to only 9% saying that you're ready and you're open to further improvement. And again, this is something that's in line with the research that we've been doing at Minitab. Organisations seem to be in a different state of readiness, and we will take this information back to ensure that we are able to support you as you go along the journey your data management journey. I'm going to hand back over to Gillian.
Having understood the volume and speed that data is being generated, we need to look at how we can automate the data analysis and the predictive capabilities in our organizations. Much is being said about machine learning and how this is the tool for this purpose. But what is it from a business perspective, and how can we use it? Machine learning is a toolkit of modeling tools that combines modern statistical analysis with computer science to deliver an automated modeling solution to quickly and accurately find actionable predictions and patterns in these large and often complex data sets. Data analysis of any type is only of value if it's robust, actionable, and timely. Traditional statistical approaches, such as linear and logistic regression, can take a naive view and do not handle some of the challenges that we find in data, such as lots of variables, missing values, complex interactions, local relationships, and finally, nonlinear relationships. The benefit of these machine learning methods is that they solve these problems, oftenly automatically. Machine learning automatically and systematically finds patterns in data, and in a short space of time will test a vast number of alternative analytic scenarios, which an analyst just physically could not do in the same time. Machine learning is not just for the continuous improvement teams. Be applied to all areas of manufacturing where data is collecting. It will provide value to the whole organization. The organizations who will gain the most from this approach will realize that it's not just the operations department. It will be extended to all areas of the business where data is collected. So I think the burning question is, what can machine learning do for you? Look at a typical 5-step analysis process. Whenever I'm presented data, I would try and follow these steps. I'd like to explore the data. How much have I got, both in terms of the number of observations, the number of predictive variables, and how much missing information. I'd like to try and find patterns. Typically, this would be done via charts and basic statistics, such as mean and mode. But with larger data sets, the patterns may be hidden from view from these basic analytical tools. I want to find relationships. Again, in smaller data sets, classical approaches like regression have served us well. But again, in more complex data, we need to use different tools. Predicting the future. With all analysis, we want to learn from the past to improve the future. And this is the first step to this. Of course, the ultimate goal is to solve problems and capitalize on opportunities. The process is robust, but when data is being created at volume and speed, The classical statistical approaches that you see in Minitab may not be fit for purpose, and machine learning tools may provide a better fit.
Okay, we're going to go to our next question, our third question, and again, thank you for participating. This information is very useful for us. The next question we would like you to answer is, what challenges do you foresee or see when you're deploying your predictive analytics and machine learning within your organizations? And please select all that apply. Do you see cultural challenges? Is there a lack of understanding? Speed of adoption, that you're slow to meet the technical requirements? Is there a skill challenge? Do you lack data scientists? And what about data management? Do you have challenges around how you collect and prepare data? Okay, still a few answers coming in. Okay, I'm going to close now and let me again and spread across each of those. We can see that the data management piece, many of you feel is the greatest challenge, that your organization will have challenges around actually collecting and preparing that data, and we hear that actually across across the market and from many customers. So again, it's very interesting to get your perspective so we can help you at Minitab overcome some of these obstacles. Thank you very much. I'll hand back over to Gillian.
Thank you, Francis. Let's look at the tools that can be found in our machine learning tool, SPM. This is a high-level overview of the modelling engines that are available in Salford. These are a set of world-class algorithms and modelling engines. The tool you choose will depend on what you need to model, the types of decision you need to predict, and the data challenges you face. In all of these tools, there is the opportunity to follow the 5 steps to explore, find patterns and relationships, predict the future, and ultimately solve problems by providing recommendations for actionable decisions. As with Minitab, we'll be providing support and training on each of these tools, what they do, when to use them, and how to interpret results. Our goal is always to help our users convert their data via analysis into actionable business decisions. So I want to talk about where big data and machine learning would fit in a continuous improvement program. I'm sure all of you are familiar with this circle of continuous improvement. I think there's 2 areas that I want to talk about, specifically measure and analyze. At the measurement phase, you're collecting the data. With these new automated systems, you'll be collecting large amounts of data in real time, and you need to find new methods to turn this data into actionable decisions. Data is the essential foundation for your machine learning journey. Therefore, you need to make sure that this data is accurate and precise. This will be a significant investment, but is critical to success of any analysis. I might also like to add that for those of you that have still got small data, it's also essential for that as well. So big or small data, accuracy and precision of your data is key to getting good analysis. Let's have a look at the machine learning. So where is this machine learning going to sit? Well, it's going to be in the analyze phase. I'm sure you all guessed that. The algorithms are there to allow you to define the goals and then in a structured but automated way, quickly investigate the variables in real time. Analysts can then focus on interpreting the results and converting these into recommended actions to improve the business. In many cases, I expect you will not have dedicated analytic resource. And even if you did, the data is going to be arriving very quickly. So in order to reap the most benefits, you're going to have to find smarter ways of unlocking robust and actionable insights from this data. This is where machine learning fits. So how is Minitab going to help you? Well, we generate data-driven insights from a 360-degree perspective. So you know we have leading market-leading solutions that allow an organization to learn from the past, discover the present, predict the future, and prescribe action. Whilst the analytical tools in Minitab and Salford are designed to analyze different types of data problems, our objectives from this software are the same. We want to make analysis accessible to the people who know the business, but are not necessarily statisticians, data scientists, or programmers. We want to provide the tools based on well-researched and reliable analytical methods. And we want to give our customers the necessary support and training to get the most from these tools. I thought it would be worth to have a little bit further look at our machine learning product SPM and why we think it is a good tool. And first of all, we understand that our customers analyze large, complex data sets. We needed to find new predictive modeling tools designed to handle the challenges that this data will present. SPM has the tools that we think our customers will need and can effectively use. The machine learning algorithms, CART, TreeNet, Mars, etc. in SPM were invented by the founders of SPM. The methodologies underpinning this software were researched and developed by these leading academics who were pioneers and inventors of predictive analytics and machine learning as we know it now. But more importantly, for users, they took these complex methodologies and implemented them in a tool that can be used by everyone, from analysts new to machine learning to experts in the field, getting results within a few clicks. With the changes in the speed at which data is being generated, you will need tools that deliver accurate results without the need for statistical experts or programmers. These tools have been tested on many commercial and academic applications versus similar tools, and they've always come out on top in terms of accuracy of predictions. So in summary, what is SPM? SPM have a range of cutting-edge machine learning tools supported by algorithms that were developed by the pioneering academic researchers and inventors in this field. These are time and market tested and constantly deliver insights and actionable decisions through advanced interaction detection. SPM can do simple statistics and regression modeling, but to realize its potential, you need to be a data-driven enterprise. This is not only collecting lots of data, but also having an organizational culture that is driven to make decisions through the use of data. SPM is a reliable tool which is easy to use by both business experts, such as project managers and quality engineers. These are often given the title citizen data scientists. But it also has the many advanced options that experts and leading researchers in this field would see as essential machine learning software. The models delivered will give users recommendations that convert into actionable decisions and will improve revenue, reduce costs, and improve quality. Important benefits of an analytical package, such as SPM, is usability and ease of interpretation. Looking at usability, most organisations will not have expert data scientists, so they need a tool that project leaders and managers can get reliable, actionable results within a few clicks. It is also no longer acceptable to wait hours or days for modelling results. Many of the other tools that are used to implement machine learning models and algorithms require a high level of computer programming skills. SPM delivers reliable predictive analytics within a few clicks. In focusing on the usability aspect, SPM has not compromised on the accuracy of the models. In many head-to-head tests with other modelling tools, SPM has proved to provide the most accurate models. Finally, it's really important that analytics get buy-in from stakeholders. Otherwise, they will not take action based on the analysis to make the required changes in the business. For certain industries, not only do you have to convince the stakeholders, but you also need to comply with the regulators. They're the other audience you have to convince. With this in mind, SPM provides a range of diagnostic tools and logs specifically allowing you to explore this information. Let's have a look at a short manufacturing demo in Salford. What I want to do is understand and predict manufacturing defaults. And I'm going to be using the TreeNet algorithm within Salford. Bit of background to this case study. This manufacturing process involves a large number of machines. When there are defects, this results in increasing costs, not only from the defective product, but also from the downtime due to the maintenance of the machines. They have a goal that they want to improve the profitability and by reducing the volume of product defects. They have collected 590 different measurements from the machines from the start to the end of the process. And we will refer to these metrics as signals. They have also collected all these 590 pieces of data on 1,567 runs of their process. And they have recorded if the run ended with defects or no defects. And they've recorded that information in a variable called status. We want to answer two questions in this analysis this afternoon. What signals, by this I mean which metrics, if any, are predictive of these manufacturing defects? And finally, if the signals are predictive of defects, then how are these signals related to the likelihood of manufacturing defects?
Just before Gillian goes to the demo, we want to ask you our final poll question. This time we want to ask, do you currently use a machine learning tool to analyze your data? Please select one. Yes, but you're still interested in finding new tools that complement. No, or no, but I do need to get a tool within the next 12 months. So there's some interesting results coming up. Let me just give you a few more seconds for you to vote. Okay. Let me share those up. So it seems that the majority of you don't currently use a machine learning tool to analyze your data. And those that do are definitely in the minority. So that shows, I think, Gillian, where people are in their journey. That's interesting. Again, thank you everybody for participating. And as I said, we will use this content and this information within our product development and plan for future webinars. Gillian, I hand back over to you for the demo.
Thank you. Hopefully you can all see my screen now. So I've opened up the Salford Predictive Modeler, and the first thing I'm going to do is open up the data set. And for those of you that are familiar with Minitab, it will look very similar in the sense of we go to File, Open. File, open up a data file. I put my data on the data set, my desktop, and it's called Secom Prepped. And you can see that it is a comma separated file. Salford does allow you to read in different formats, but I have a comma separated file. So I'm just going to click open. First dialog screen. So hopefully you can all see the first dialog screen. On the right hand side of the screen, you'll see a little box that's highlighted with the word data. And this just gives me some summary information about the data. So you can see I've got 1,567 records, 591 variables. And on the left-hand side, I've got an alphabetical list of all my variables. Okay. Along the bottom, you'll see a box that's labeled activity. I put my mouse by the word activity, and you'll see a range of buttons along the bottom. Okay. Some of these, you can see what they might do. So that's going to produce basic statistics for you. Graphs will do me some basic charts, correlation, word you're probably familiar with. But what I always like to do, whatever data I get presented, is first of all just have a quick look at it and eyeball it and see if there are anything I need to be worried about. So I'm just going to click on View Data. For some reason, yeah, I think you can now see what I was seeing. For a while, I was a bit panicky there because you were getting a blank screen, but I think it's just the slowness of the internet signal at the moment. Okay, so if you can look across the top, you can see our variables starting with signal 1 all the way through to signal 590. Of course, these metrics don't mean anything to us. In your case, you probably would label them, you know, with machine A, temperature, machine B, pressure, or whatever they might be, more meaningful variable names. And then those metrics would mean something to you. If I scroll to the So I've scrolled to the far right-hand side, and the last variable that I have available is called status. This status is the indicator whether or not a defect or a non-defect, the run resulted in a defect or not a defect. So if I see the number -1, that's a great run, no defects. If I see the number 1, it means there were defective products in that run of all my machines. Okay. What I want to do now is I'm just going to start by running a model. Okay. I'm going to click on the word model at the top of the screen and a model. The dialog box will pop up on your screens in a few moments. You now have the dialog box, and you can see the word model is highlighted. At the top, we have a number of tabs to set different options for modeling. For today, we'll be mainly using the default options, so we will not be entering these tabs. The table underneath defines our target value. So if you look on the left-hand side, we have a list of variables, and the first column header is target. What I need to do is tell Salford what am I trying to predict. Where's the variable which has the information about what I'm trying to predict? And this is the variable called status. So I'm going to scroll to the very bottom of my data set and click on status. Okay, so now that's highlighted. And if you look on the right-hand side of the dialog box, there's a little box called target value, and you'll see that status is highlighted there. What we now need to do is tell SPM that we want to select all the signals as predictors. So I'm going to click on the top of this column that says predictor, and then select all the predictors. Obviously, if I didn't want certain ones for whatever reason, perhaps I knew that they hadn't been collected correctly, I could uncheck any of these. Okay, so that's what we've done. Now, what I need to do is I need to tell SPM whether I want to predict non-defects or defects, which is my target. Yeah, well, you know, do I want to work out the probability of a defect or the probability of a non-defect? Well, I want to work out the likelihood of a defect. And this is done, and this is called the focus class in SPM. So there's a button on the right-hand side called Set Focus Class, and I'm going to click on that. Okay, so you can see now that this dialog box has been populated with the two values that status takes. What I want to do is say I'm interested in the defects. The defects in this example are coded with the number 1. So I'm going to highlight 1 and then click on the greater than sign in the middle, and it's been shifted to the right-hand side, and that's now my focus class. And I'm going to click OK. I want to do one last thing. That's just going to make it a little bit easier to read the reports. You know, -1 and +1 for status, it doesn't really mean anything. So it would be quite nice to actually label them as defects and non-defects. So I'm actually going to use one of the options at the top. And I'm going to use this option called categorical. And what I'm going to do is I'm going to put labels against that -1 and +1. And to do this, I'm going to click on Set Class Names. Okay. So we now have a new dialog box popped open. I'm going to click on Status, and then in the file value cell, I'm going to put -1, and then I'm going to, in the display value, say, instead of displaying -1, I want to display the word no defect. I'm going to do the same for the defects. I'm going to put the number 1 in, and then the label I want to use is defect. Okay. So now on all my output, instead of getting -1 and +1, I'm going to get no defect and defect. Hopefully, for users that aren't familiar with the data that you're presenting these results to, it'll be easier for them to interpret what's happening. So I'm going to click Done. Just need to make a few more checks on my model. I need to make sure that I've got the right kind of target. Well, I have got binary data. The results are either defect or non-defect, one of two things. So I'm going to leave that with my target type at the top. And I want to check that I'm using the analysis engine. Of course, we haven't discussed today why I chose the TreeNet gradient boosting machine. That is really for another day. But I just need to make sure that I've chosen the right one. And you can see to choose the type of engine I want to use, I click on the drop down. But I'm going to stick with my TreeNet gradient boosting machine. And then I'm going to click Start. SPM now is doing some serious number crunching for me at the moment, building a series of decision trees. Pop on your screen soon. So I hope you're now seeing the same as I'm seeing, and at the top you've got some summary information about our analyses. You can see that the target value is status. We had not 590 predictors, and I've already got a little bit of information because underneath that number of predictors, there's a field that says important predictors. So of those 590, SPM has classed 260 of them as important. The way TreeNet works is it iteratively builds by default 200 small decision trees. I should add the defaults for the number of trees and the number of nodes, tree size, you can see at the top, can be changed. I've used the default. However, at the top, can you see underneath the trees grown, it says trees optimal. Okay. And it's saying that we only need 164 trees to get the optimal solution. I'm going to come back to this. Why did we choose 164 in a few moments? Let's have a look at the chart underneath. So if you have a look at the y-axis, the vertical axis, you will see that it says this measure is the negative average log likelihood. And this is a measure of the performance of a model on the same data set. And the smaller it is, the better. Along the x-axis, we've got the number of trees. And you can see that over the number of trees, as the number of trees increase, this net average log likelihood reduces. Okay. You can see 3 lines on the chart, and I want to explain what each of these 3 represent. Now, whenever we do modelling and we're trying to make predictions based on the past, we have to be really careful not to overfit the data. You know, we're taking the past to be representative of what's going on in the future. And overfitting can be a problem with all modelling, not just machine learning. Now, in SPM, there are several methods of testing the model to try and avoid problems like this. In this case, what I've chosen to do is to take this data, these 1,500 records, and I've put 80% of them, I've selected a random sample of 80% of them into a learned sample. So can you see the blue line on the chart? This represents the learned sample. Yeah? And I've put 20% into a test sample. So what happens when I'm building my decision trees, that test sample is set aside. Okay. So then I'm going to build my decision trees. At each iteration, TreeNet takes a sample from that 80% of my data, and that is the green line. At each tree, after I've built each tree, I test that tree, that iteration of the tree, on my test sample. That's the red line. I decide that I've reached the optimal point when I can see no further improvement in the test line. So if you look at the number 164, that's my green dotted line going down. This tells me, you can see that it's a pretty flat line to the right of that 164. So this is saying to me, based on my test sample, this was the best we could get. We could see no further improvement. Okay. In the top right-hand corner, you can see there's some summary information for some other measures for model improvement. Again, you can just swap the chart at the bottom by using the buttons at the bottom. So for example, you can see one of the measures is receiver operator characteristic curve. That's a measure of how well the model is separating the 2 classes. The closer to one, the better. Okay, and you can actually swap to plot that on the chart. I'm not intending to do that with the button shown at the bottom. We had 2 particular questions we wanted to answer. We wanted to say, well, what are the most important signals? It tells us already that we know that 260 of the 590 are important, but what are the real most important ones? So to look at this, I'm going to look at summary. Okay, so now I've opened up the summary dialog box, and again, we've got lots of tabs at the top showing us different ways of slicing and dicing our output. But because I have a specific question about variable importance, I'm going to straight away click on the variable importance tab at the top. Okay. So this table is listing the predictors, those signals that we collected, the 590 of them in order of importance. You can see signal 60 is the most important. Okay, and we've given that a score of 100. then everything else is ranked in relationship to signal 60. So if signal 60 is the best, given a score of 100, then 65 you can think of being as only 85% as good at identifying the defects. And if I scroll, all 260 important predictors are shown on this list. So if I scroll down, just scroll down a little bit, you can see, hopefully you can see, I'll just make sure it's popping up on your screen. You can see the numbers start going down. For example, if I look at signal 334, it's around about 50% as good or as important at identifying defects as signal 60 is. Okay. Now, this may ask the question is, well, you know, do I actually need all those predictors? You know, I'm a great one in wanting simple models. The less things you have in models, the easier it is to control it. So maybe what I would like to do is maybe, you know, select, you know, all of the ones that are 50 and above. And I can do that. I can use this keep and go feature at the bottom here, select the ones I want to keep and run the model again. Unfortunately, we don't have time to do that today. Even doing that manually could take quite a lot of time. So there are options within SPM for you to do that automatically, but in doing that, not lose any results. So you can see, you know, if I look at the top 50, you know, what's the result going to be if I look at the top 75? So that's our variable importance. I see that time is ticking on. So let's now have a look at signal 60, because signal 60 was the one that was most important. Let's see, because we need to know, well, what setting for signal 60 is going to be important. So what I want to do, I'm going to go back to my summary screen, and what I'm going to do is display plots. Okay, now you'll see that as part of the model build, it has created one univariate plots for all my signals. I'm going to look at signal 60. Good news is it keeps it in the order, the most important first. So signal 60 is what I'm going to look at. Just pop that open so you can see signal 60. So you should be seeing a chart for signal 60. Let me explain what's on the chart. So if you look at the x-axis corresponds to the settings for signal 60, whatever that measurement is. And you can see it takes values between -30 and +30. The y-axis describes the likelihood of a defect. So the higher the number, the higher you are up the on the y-axis, the more likely there is a defect. And the 0 line is like the average defect line. Okay. So what we can see here is actually with a signal setting less than about 5, it stays below, you know, there's a less chance of having a defect. Once you get to 5, everywhere between 5 and around about 15, what you find is it's rapidly increasing the chances of having a defect, and then it plateaus out from 15 onwards. Now, it would be up to me as the analyst or you as the process manager to actually interpret, well, what is signal 60? Is it the temperature? Is it the time? Is it the pressure? It could be any of these. What does it actually measure, and how can I control that? I'd like to swap back to my PowerPoint now and pull together some results on that. So, putting that all together. Using the TreeNet gradient boosting, the manufacturer identified that signal 60 was the most important variable influencing the number of defects. Of course, we don't know what signal 60 represents. It could have been time, temperature, pressure. If it was your data, you would know how to interpret it. However, from the charts, we know that a setting between 5 and 13 increased the likelihood of defects. When they actually made changes to this signal, they reduced defects, which resulted in a $45 million increase in annual product revenue. So let's recap. Consider machine learning. Machine learning is a set of algorithms that allows us to overcome the data challenges that are often found in data sets. Things like nonlinear relationships, effects, complex interactions, and one of the big ones that I find people will have missing values. We want from our machine learning systems are tools that are easy to use, that within a few clicks will deliver accurate predictions, where we can understand the relationship between predictors and response. These then can be converted into actionable decisions to solve your business problem and fully exploit any opportunities. Minitab and Salford bring together decades of credibility and a broad portfolio of analytical solutions. We generate data-driven insights from a 360-degree perspective. We have market-leading solutions that allow your organization to learn from the past, discover the present, and predict the future. And ultimately, start taking actions that can anticipate the way your business needs to grow and change, and make these into future recommended actions.